Today we're going to begin Chapter 7, which is all about the normal probability distribution, and also talk about some other continuous random variables as well. So again, the big idea with something that's continuous is that there are no gaps in the possible values of the results. So unlike discrete data where you'd have, say, the number of children in a household, it's discrete because it's either there's 2 children, 3 children, 4 children. You're not going to have 4.5 or 3.1 children. There's 2 or there's 3, nothing in between. For continuous data, it allows fractional values and it allows decimal values. So to start with, we've got properties of the normal distribution here. So to calculate probabilities, you have to have a probability density function. So for the PDF of a continuous random variable, it doesn't ever actually give you the probability of a specific result happening. Because fun fact, that's actually always equal to 0. It's so minusculely impossible to get 3.1 versus 3.11 versus 3.12 that you instead have to talk about ranges of values to describe probabilities in a meaningful way. And so the probability from A to B, this space A less than or equal to X less than or equal to B. That's basically another way of saying X is between A and B. And so that corresponds with the area under the curve of the function. So for a function f, if it's going to be a probability distribution function, you have to have 2 criteria. The probability has to be positive for all possible values because there's no such thing as a negative probability. The other thing that has to be true is that the entire area under the graph has to equal 1 because the total probability of all your outcomes is always supposed to be 1. So for instance, let X be the size of an insurance claim, and that's measured in thousands of dollars. Assume X can be any number between 0 and 4. And there is a typo here, which I will change. That should be 0.25x. So it can be anything between 0 and 4, and the PDF is given by the function f of x equals 0.25x. So the first thing we need to do is confirm that that is a valid probability distribution function. So the way that we could do that is we basically need to do f of 4 minus f of 0. More generally, if you're on a range from A to B, what that means is that you need f of B minus f of A to equal 1. So f of 0 is f of 4 rather is 0.25 times 4 minus f of 0, 0.25 times 0. 0.25 times 4 is the number 1. 0.25 times 0 is the number 0, and 1 minus 0 is 1. So yes, that checks out. You could also check and you should make sure that it's valid because every value should be positive. Probably the easiest way to do that would be to actually graph this. This is actually an equation of a line. And if you actually draw that line, it will show you that every value is on the positive side of the x-axis. So next they say find x less than or equal to 2. So here what I'm going to do this is basically asking for the interval from 0 to 2. So what I'm going to do is I'm going to do f of 2. And they didn't give me a bottom end, but again, we're limited to 0 being the lowest possible value. So we're going to do f of 2 minus f of 0. So you plug in 2 into the function, 0.25 times 2, and then subtract 0.25 times 0. 0.25 times 2 is 0.5. 0.25 times 0 is 0. And you work that out and you get 0.5. So there's a 50% chance that the values are 2 and below. And that kind of makes sense because we're limited from 0 to 4. So 0 to 2 is half of that. Again, let's fix this typo here. All right, next you need to find the probability when x is greater than 2. So this is going to be the interval from 2 all the way up to 4. Because 4 is as high as it goes, and we're saying x has to be greater than or equal to 2. So we're going to start as low as 2, and then we're going to go up. So for this, we're going to do 0.25 times 4. And then we're going to subtract 0.25 times 2. That's going to give you 1 minus 0.5. And subtract those, and you will get 0.5. Which makes sense because the other 50% was below 2. So then the other 50% has to be above 2. Here they're giving you the interval from 2 to 3. So that would be, you could write that as an interval from 2 to 3. And that just means that they want you to find what f of 3 minus f of 2 is. So if we do that, that's going to be 0.25 times 3. And then minus 0.25 times 2. That's going to be 0.75. That's going to be 0.5. And if you subtract, that is going to give you 0.25. So there's a 25% chance that will happen. So the continuous uniform distribution. X is a continuous random variable. It can take any value between C and D. Every value of X is equally likely to occur, and so that's called a continuous distribution. So the PDF for a continuous distribution is given by 1 over D minus C. And so if it's continuous, you can find a probability. If you're doing the range from A to B, you're going to do B minus A, and then divide that by the length of the entire interval, which was D minus C. Now, we actually saw this in action already because the examples that I was just doing and the way I could look at it and tell immediately that there was a typo was because of this fact. The PDF for the examples we were just doing is 1 over 4 minus 0. So then this is going to, or times x. So then what we ended up with was 1/4 times x. That was the PDF. So and actually that was just it was just 1/4. But anyway, so that's how you would find the probability there. That's how I was able to tell it's 0.25 or 1/4. So you do 1 over 4, And then with this, you just find the interval from A to B, and then divide that by the length of the entire interval, which is D to C. You can calculate the mean for this. It happens to be C plus D divided by 2. The standard deviation is D minus C over the square root of 12. We're not going to get into the gory details of where that formula comes from and just why on earth it's root 12 of all things. Just kind of go with the flow and just accept the fact that that's the formula that'll tell it to you. So assume that x follows a continuous distribution on the interval from 2 to 10. So then what this would mean, C is the low end number, that's 2. D is the high end number, that's 10. Here, we're saying x is less than or equal to 5. They don't directly spell it out for you, but because the lowest we can possibly go is the number 2, this is really telling you what's the probability of it being between 2 and 5. So then in this case, this one they call A, and this one they call B. So for this probability here, for x less than or equal to 5, we're going to do B minus A over D minus C. So B minus A is 5 minus 2. D minus C is 10 minus 2. It can happen sometimes where B is the same as D or A is the same as C. That can happen sometimes. 5 minus 2 is 3. 10 minus 2 is 8. So then 3 out of 8, or what is that, 0.375, that would be the probability that that would happen. All right, let's try another one here. So we want x to be greater than 7.5. Now again, they don't come out and spell this out for you, but this means (7.5) is less than or equal to x, which is less than or equal to 10. Mouse is going crazy here. Less than or equal to 10. So then A is going to be this number, B is going to be that number. So they didn't spell it out for you, but again, from the original problem, we know the highest this is ever going to go is 10. So we're going to do this same formula that we did before. We're going to do 10 minus 7.5. We're going to do, on the bottom, we're going to do 10 minus 2. That's going to give me 2.5 over 8. Let's see what 2.5 divided by 8 is. That is 0.3125. All right, there you go. That is that probability. Here's another one. This time they do have, they do give me directly the two numbers that we're interested in. So the low end is A, the high end is B. And again, we're going to do B minus A divided by D minus C. And that one is C, that one is D. So what is this? This is 5.9 minus 2.7 all over 10 minus 2. The bottom is going to be 8. 5.9 minus 2.7 is 3.2. So then we need to find what is 3.2 divided by 8. That is 0.4. Okay, there you go. This one's a little bit different. They asked for the 90th percentile. And that basically means that what the decimal should equal when it is all said and done. the decimal should be equal to 0.90. So for this situation, we're basically going to have 0.90. That should equal some value b that we don't know minus the bottom of this distribution, which is 2, all over the entire length of the distribution, which is 10 minus 2. And we've seen from when we've done this before that the bottom is just equal to 8. So you're going to have b minus 2 over 8. So if you're going to solve this, you'll want to multiply both sides of this equation by 8. I'll cancel that out. 8 times 0.9 is 7.2. That's equal to b minus 2, so then you would add 2 to that. 7.2 plus 2 is 9.2. So that's b, or in this case, they're calling it p sub 90. P sub 90 is 9.2. And that's going to live at the 90th percentile, which means that its probability, it accounts for 90% of the results. The amount of time in minutes the customer must wait between placing and receiving an order is uniformly distributed from 0 to 12. Find the probability that they will have to wait more than 4.5 minutes. That basically means 4.5 is as low as it goes, and we can go as high as the very top, which would be 12. So then this probability, you're going to do 12 minus 4.5, and then divide that by 12 minus 0. And this is the length of the entire interval. 12 minus 4.5 is 7.5. 12 minus 0 is 12. So then 7.5 divided by 12 is 0.625. That'll be the probability for that one. What's the probability that they will wait less than 9 minutes? Okay, so that means you can go as low as you can possibly go, and then the highest you ever get is 9. Because you need to be 9 or less than what you're interested in. So we're going to do 9 minus 0 over 12 minus 0. That's going to end up giving you 9 over 12. And that's going to be 0.75. Let's see, what's the probability? It's between 2 and 8 minutes, all right? So this is pretty straightforward. The low end number is 2, the high end number is 8. So to find this probability, you're going to do 8 minus 2 over 12 minus 0. 8 minus 2 is 6, 12 minus 0 is 12. You work that out, you'll get 0.5. Find the 70th percentile. All right, so 70th percentile, that means we want it to equal 0.70. The bottom is 12 minus 0, the entire interval. And then here we're going to have some number that we'll call b, and then minus the lowest possible number, which is again 0. Because percentiles are always measured from that number all the way down to the bottom. That's going to simplify to 0.7 equals b over 12. To solve this, we're going to multiply by 12. And that will cause those to cancel out. So if you do 12 times 0.7, you get 8.4. So 8.4 minutes is the 70th percentile of wait times. So, continuous distribution is basically just a flat line of all the possible outcomes. The standard way that we see a lot of statistical situations in the field is there tend to be what's called a normal distribution. This is it's what's known as a bell curve. And it has a very, very complicated probability distribution function. If you're interested, there it is. We're not really going to use this formula itself, but that's where it is. It's kind of hideous, but so there you go. So some features of the normal curve and its graph. It is bell-shaped. If you've ever heard reference to the bell curve, this is it. Let's see here. The mean and median. One thing that's special about it is that the mean and the median are actually the same. So it's not, the data are not skewed in any particular direction. You don't have lots of really small values or lots of really large values kind of offsetting how the distribution falls out. The standard deviation is going to tell you how peaked it is. So basically, when the standard deviation is small, most of the area is around mu, which is the mean. So basically, a small deviation is a high peak. That basically means the data is packed in really close together. If the standard deviation is large, that's going to give you a short peak. So it's going to give you a much wider and spread out curve because the deviation is larger. The total area under the curve is 1, which must be true if you're a probability distribution function. 50% of the area is under the mean, the other 50% is above the mean. And then 68.26% of the data, roughly, are going to be within one standard deviation. So say the standard deviation is 100, or I'm sorry, say the mean is 100 and the standard deviation is 10. That would mean that if you go up 10 and down 10, you get 68%. So if our mean was 100, if the deviation's 10, that means from 90 to 110, that's where 68% of the data are. So let's jot this down. So let's just say, for the sake of argument, that we had a, why are you not drawing? So let's just say, for the sake of argument, that mu was 100 and the standard deviation was 10. So if you go down 10, that would put you at, say, 90. If you go up 10, that would put you at like 110. And that's basically telling you that 68% of the data are between 90 and 110. So that's what that would mean. Now, if you go out 2 standard deviations, so if you go down another 10, for instance, in this example, that would take you down to 80 and up to 120. And this tells you that 95% of the data are between 2 standard deviations. And so that's, that in this example, that's going to be from like 80 to 120. So 95% of your data, roughly, are between those 2 values. Meanwhile, if you take this one stage further, if you go down yet another 10, so altogether you go down 30, because you're going down 3 times, that'd take you to 70, up to 130. So then in that kind of a situation, You have yourself a bell curve, like so. You go out really far. Here's 70. Here's 130. And so 99.74, virtually all of your data is going to fall within that range. So here's an illustration there of the bell curve. So that's just kind of an introduction, and then the second half of this chapter, the next section, we're going to be dealing with the bell curve in greater detail. But for now, that is what we have to say so far about the bell curve and the normal distribution, which is by far the most commonly used continuous distribution that's out there.